Right, so we're looking at a question that crops up early on an MEI C4 paper. It's question 2. That's telling you that it's pretty much bookwork. It's something that you should be able to recognise, repeat the method and get the marks in as short a time as possible. It shouldn't take you really much longer than 5 minutes to complete this once you've recognised it. So it's a binomial expansion. So if we take a look at what you have in your formula book, you can see you have two different cases. You have one, a plus b to the n, and you have a general case 1 plus x to the n. Now, the expansion that we're asked to do here is to a power of 3 over 2. This first expansion states clearly that it only works when n is a positive integer. So it's a positive whole number. Ours isn't a whole number, it's 3 over 2, so we can't use that expansion. Which leads us to this second general case. And you can see clearly in the general case, we can't use it until we have the bracket in terms of 1 plus x to the power. So the first bit of maths that you need to recognise and then deal with is getting that 4 out of there. So if we do that first of all, if I look to take that 4 out as a common factor, then what I have to do is write the internal part as 1, because 4 times 1 is 4, and then in order just to have the x there, we would write the coefficient of x as a quarter. Check it by multiplying out. 4 times 1 is 4. 4 times x over 4 is x. And that is all being raised to the power of 3 over 2. Now, when you're raising multiple factors to a power, then you can raise each internal or each individual factor to that power as well. So we can write that as 4 to the power of 3 over 2 multiplied by 1 plus x over 4 to the power of 3 over 2. That level of indices would be something you would be expected to deal with comfortably on a higher tier GCSE paper. The over 2 bit is telling you that it's a square root of the base, and the numerator part, the 3, is telling you that that is cubed. So we can write that as the square root of 4 cubed times 1 plus x over 4 to the 3 over 2. Square root of 4 is 2, 2 cubed is 8. And now it's in a form that allows us to use this general case, where for us n is 3 over 2, and the x part of it has to be all of it, so it's x over 4. So we're expanding with n being 3 over 2, and the x part, actually, we're working with x over 4. So our expansion then will be 8, and then in case you're referring to this, 1 plus nx, so 1 plus n x plus n times n minus 1 over 2 factorial x squared plus n 3 over 2 times n minus 1, well 3 over 2 is 1.5, less 1 is a half, x over 4 all squared, and remember the all over 2 factorial as well, which is the bit that's most commonly left out. And we only need to do the first 3 terms, first term, second term, third term, so we can just show that that expansion does continue, but we're not bothered with that expansion. Let's tidy up now what we've got here. So let's keep the 8 out first of all. that becomes a 1, 3x over 8 in that part, and now in this part the numerator is going to be 3. The denominator is going to be 2 times 2 is 4, times 2 is 8, times 4 squared, which is 16. So 8 times 16 x squared. Now we can multiply in the 8. So we get 8 plus, those will cancel, giving me 3x. And then with this one, the 8's will cancel, leaving me 3 over 16x squared. So that is my final expansion of that, and it's approximate because I'm not continuing the expansion. So go back to the question, find the first 3 terms in the binomial expansion of that. 1, 2, 3, done. State the set of values of x for which the expansion is valid. Again, this should just be something that you can draw from your book knowledge. There's no reasoning or anything involved here. The expansion, going back to your formula book, of this is valid for positive values of x which are less than 1, mod x less than 1. So for us, it's going to be valid for mod of x over 4. Now you might be happy just rewriting that. I'll go through the various steps in case you're not. 4 is a positive constant, so there's no reason why I can't write that like that. And then if I multiply throughout by 4, I get that modulus of x is less than 4. Another way you could do that is you could say that for that to be true, then it means that it must be between -1 and +1. If you multiply throughout by 4, you get that. Those are equivalent statements. They mean exactly the same thing. So either of those will give you the marks for that. So that's it. That's the complete question. Let's take a look at how that would be, how the marks would be awarded for that. You would get a method mark for rearranging that into a form where you can expand it. So there's a method mark for getting down to that point. Second method mark is for this line where you're correctly expanding the first 3 terms of the binomial expansion. However, if you ended up without the x over 4 with just an x in there, so long as the coefficient parts were correct, the 3 over 2, 1 over 2 and so on, then you would still get that method mark. There are 2 answer marks. The first one is for that part, so you have to get both of those parts correct to get the A1 for that, and then the second A1 is for that, and then finally there's a standalone mark for the correct validity. So even if you messed that up, so long as you correctly wrote down what the validity was, then you would get that. So that gives you a total for that question out of 5. 1, 2, 3, 4, 5 marks. 5 marks that you'd be looking very hard to get full marks on.